Hello and welcome to another episode of Electronics Made Easy. We're going to make this an episode that is very interesting, we hope. Today we're going to talk about resistors. There are three types of resistors. There is the fixed resistor, the tapped resistor, and the variable resistor. The fixed, of course, is unchangeable. Whatever the ohm value is for that, or the resistive value for that particular resistor that's what it is. It stays there. A tapped resistor means there are several places on the resistor that you can pick what ohmic value you want. And then there's the variable, and these are infinitely variable. They can be changed from 0 all the way up to what the value of the entire resistor is. Typically they're called pots or variacs or those kinds of things. Let's start by talking about fixed resistors. Fixed resistors are the ones that cannot change their value. They are what they are. You're not going to change that. And they are valued in ohms, and that is their resistance or their resistive value. So let's talk about how we identify how many ohms or what the resistance is of a particular resistor. Okay, if you can remember Bad Boys Race Our Young Girls, but Violet gracefully wins, then you've got it nailed. You don't have to worry about it anymore, because those stand for colors. And black is equal to 0, brown is equal to 1, red is equal to 2, orange is equal to 3, yellow is equal to 4, green is equal to 5, blue is equal to 6, violet is equal to 7, gray is equal to 8, and white is equal to 9. The only ones that might be confusing to you are black, brown, and blue, because they all start with the letter B. The rest of them should be fairly obvious. So just remember, it starts with the darkest going to the lightest, because black is darker than brown, and brown is darker than blue. So you should be able to remember all of these by that. Let's take a look at what a resistor looks like. This particular one is a 2 watt. As you can see, it has 4 color bands on it. Each of those bands helps decipher the value and tolerance of this particular resistor. This one is a 2 watt. The purpose of a resistor is to dissipate power. Therefore, they are rated in watts. And do not get watts confused with resistance, because the size of the resistor has absolutely nothing to do with the ohms of the resistor. So this chart shows the relationship between the size of a resistor and its wattage. We have everything from 1/8 of a watt all the way up to 2 watts on this chart, which is typically what you will find in most of the applications for electronics of a resistor. Of course, they do get exceptionally large and extremely high power, or they get exceptionally small and extremely low power. This chart explains 4, 5, and 6 banded resistors. I will leave it up for a moment for you to look at, and I'm sure you can figure it out. The first color band tells you the first number in the series. On this resistor, the first band is red, and red, if you look at your chart, is the number 2. So 2 will be the first number in this particular resistor's value. The second color band gives you the second number in this series of numbers. In this case, the second band color is black, and black equals 0 according to our chart. So the second number in our series will be a 0. So we're at 20. The third band gives you the number of zeros that go behind the first two numbers. On this resistor, the third band is green, which equals 5 according to our chart. So we take the number 2 and 0 and add 5 zeros behind it, which gives us the number 2 million. So this resistor is 2 million ohms, or 2 megohms. The fourth band gives you the tolerance, and gold is equal to 5%, silver is equal to 10%, and no band on the end is equal to 20%. This resistor has a gold band which is equal to 5%. So this resistor is equal to 2 million ohms with a 5% tolerance, which means it can go from 1,900,000 ohms to 2,100,000 ohms and still be within tolerance. And that's how you read the color bands on a resistor. Okay, we're going to start with a 1/8 watt resistor, which you can see here. It's very small. This particular one has no value written on it. It has no color bands or nothing written, so we're just going to check it and see what it is. So it is 0.497 megohms, which means it's about 500,000 ohms. So it's probably supposed to be a 1.5 megohm resistor. Okay, so this one is a 100,000 ohm because it is a brown, black, yellow, and brown, black, yellow is 100,000 ohms, and it has a 10% tolerance because it has a silver band on it. So it's going to be somewhere between 99,000 and 101,000 according to. Okay, so it comes out to 98.3. So it's outside of tolerance, but it's still, we've got a good idea of what the resistance of this resistor is. So that's an example of how it should not work out. All right, let's go to the one that we looked at before, which should be 2 million ohms. This is the 2 watt that we looked at previously, and it should read 2 million ohms plus or minus, so it's 2.229 megohms. So that's pretty close. That should work. It could be that, you know, we've got some losses through the rig I've got hooked up here. So anyway, like I said, 2.227 megohms is what it is. So that's 2,227,000 ohms. Now we're going to look at another 2 watt one. It is yellow, which is 4, violet, which is 7, and orange, which is 3. So that's 47,000 ohms. So it should be somewhere around 47,000 ohms. So let's see what we get here. This is according to the color band. So what we've got is 48.2 k ohms. So that's 48.2 thousand. So that's 48,200 is the reading we got. So it's within tolerance. So that's a good one. Okay, now this is an example of one that is very small in ohms, but it has a fairly high wattage. It's 5 watts. So let's see, it says it's 0.22 ohms. Let's take a measurement and see exactly what we've got here. It's going to be very small. Okay, so we've got, if I can hold my finger on it, 0.6 ohms. That is probably, well, let's see if we can get a better reading here. Let's sit it down. Keep my fingers off of it. Okay, I got 0.6 ohms thereabouts, so it's pretty far off, but I'm thinking a lot of that is meter lead resistance and maybe some contact resistance where I'm touching the leads. There could be some corrosion on these leads coming out of the resistor. Low ohm resistances like this are quite hard to read. Sometimes you have to have a special instrument to read those. Alright, let's go to the next biggest one. And this one has no markings on it, but I just happen to know it's a 10 watt. And let's see just exactly what we read with it. Let's see what the ohm value is. Okay, it is 100 ohms. It's 99.3 approximately ohms. So we've got a 100 ohm resistor and it's 5 watts. This one particular one is ceramic, and the last one was also ceramic. This one is a wire wound, and the reason I know this is because I have taken one and I stripped the outer coating off, and you can take a look here. As you can see, it's a wire inside wound around a core, and it's coated with a ceramic coating that this is the same resistor. One has the outer coating removed, the other one doesn't. So you can see this is a wire wound resistor. Let's see what the ohmic value of this particular one is, and the terminals are here and here. Let's turn it around so you can see it better. So here's that particular one is 2.5 ohms, so it's a very large resistor, probably 10 to 15 watt from guessing, just looking at the size of it. And it is only 2.5 ohms, which is not that unusual. The bigger they are, the more heat they have to dissipate. Here's one that's a little bit smaller. It's also a ceramic. This one is 50 ohms according to what it says on the outside, so let's see what it actually reads. And it reads 50.2 ohms. That's pretty good. That is not bad at all. That's pretty close, and it's a 5% tolerance, so it's well within its tolerance. Alright, this is a metal coated resistor, and it is a 50 watt with a 1% tolerance, and it should be 3 ohms according to the print on there. So let's see, it is 3.5 ohms, and we may be getting again 3.4. We may be getting some resistance in the wires of the leads. There may be some corrosion on the tips. It could be any of those things. Alright, let's go to a different type. Well, this is actually the same type. It's ceramic, but it's a different type. This particular one is 10 ohms and 50 watts. So let's see what it reads here. Let's see what kind of value we got. And it is 10.4 ohms. That's pretty good. So that's very close. All right, let's take a look at a different one. This one is also a resistor. This one is a wire wound, and it is looks like 7 ohms, 95 watts. So it's a 95 watt. I don't know if you can see that or not, but it is on there. It's 95 watts, 7 ohms at 5%. Let's see what we read. Let's see what the meter tells us it is. Okay, now we've got that. And the meter says it's only 1.5 ohms. Let me reread that. It's really small. Okay, so that is 1 ohm, not 7. Sorry. That was my bad. I'm old and I can't see well. Okay, here's another one. This is 150 ohms. So let's see if it actually reads 150. See, you can probably see that one where it says 150 ohms on it and 60 watts. So let's see. 149.6 ohms. That's pretty close. I would say that was very good. All right, we got one last resistor here, and this one is 220 ohms at 10%, and this is probably 50 watts, and that sounds about right. So this should be 220, and it's 224 ohms. So that, again, that's not too bad. This is also a wire wound on a ceramic core. As you can clearly see, it's very well identified on the outside. So this is a 50 watt resistor. Now let's pull the bad boy in here. Now this is going to be extremely low ohms. There's not going to be much on this one. This actually came from a radio station, and it is very low ohms, I'm sure. I have not tested it before, but I can about guarantee you it's very low. Okay, it is 0.5 ohms, but I do not know the wattage on it. There's no print on here. However, I would guess this is probably close to 500 watts if I had to guess. It's pretty heavy duty. Okay, that finishes up most of the fixed resistors. Of course, I have some more. As you can see, I've got quite a few here, and we can test more later on a different video if you'd like. Now let's go to variable resistors. Variable resistors, there you can see I've got a few here. They go all the way from this size. This is a potentiometer, and as you can see, it's pretty small. So they go all the way from this size all the way up to and including even larger ones. But this particular one is rated at 14.1 amps. The ohm is 2.8 ohms. So let's see if that's true. Let's see if it really is 2.8 ohms. Now here's another one. Let's see what we've got here. This is this one is, I can't see. I can't tell what it is. So let's put the meter on it and see if we can tell what ohm value we have. It's probably a reasonably high wattage. And again, I'm reading nothing. I think these are just bad. Yeah, I think both of these are just no good. Let's see if we can read anything here. No, this one's just plain bad. Oh, I see. See, there's the wire, and it's broken. So that's why this one is bad. You can see that it's bad. But anyway, again, it shows you how large these can get. They can get pretty big. This one would be, I don't see an ohm value on it. I don't see a wattage on it. But anyway, again, you can see it's a pretty large power stat, and it is for high power usage. Now this is a 2-watt pot. I happen to know that, just right offhand I know. So this one is 2 watts, and this one is 1 meg ohm, so that's 1,000,000 ohms. This one should be 1,000,000. So let's see if it is or not. Let's put our probes on here and see if we get 1,000,000. 1.135 meg ohms. So yes, we do. So if I go, here's the thing about the pot, the potentiometers. If I go from one side to the wiper, the center pole is called a wiper on these. And if I put it right here, I'm getting a reading of 1.1 ohms, so it must be turned all the way down on that side. So let's bring it, as you can see, as I bring it up, this isn't doing very well, but now we're up to 90K, 90,000. Here we are at 200,000, and if we keep going, we should get up the full value of 1 meg on. That's a half a meg approximately, and I'm still turning. There's 0.7 megs, 0.9 megs, and right there we're all the way up. Well, it should be, yeah, there you go, 1.1 megs. That's about right. Let's switch and go to the other side. Now when one side is at maximum, the other side is at minimum, so we got 0.8 ohms there. So let's take it back the other way, and it's doing exactly the same thing. It's going up in value as it should, and there we are back at 1 meg again. And all I'm doing is turning this knob right here. I'm turning that, and it's about 300 degrees of turn on this. You can turn it approximately 300 degrees, and you can go from 0 to 1,000,000 ohms in that span of 300 degrees of turning that. This is the same thing, only it's a dual. It's 2 pots in one, and looks like these are, it's kind of hard to see again, these are not marked, so we would have to test this. So let's see what values we have. They may be the same or they may be different. So that one is 5 megs, and the front one is 1 meg. So there's a 5 meg on the back, there's a 1 meg on the front, and again you can turn the 300 degrees and you can get from 0 to maximum on both of these. Now this is a multi-turn pot, and as you can see, it has a special knob on the front. And if I hold this, okay, it must be locked. Let's see. Yep, it's locked. But anyway, let's see what the value on this one is. If we go from one side to the other, this one is 500 ohms because it's 0.5 K ohms, so it's about 500 ohms total. So we can go from 0 to 500 with this one. And it is multi-turn. It can turn up to 10 times. Alright, let's take a look at a different type. Okay, this one is 350 ohms according to its label, and let's check it and see what it actually is. It may be a bad one, I don't know. I've just grabbed these out of a bin. Yes, 350 ohms. That's actually pretty accurate at 350.3 ohms. That's very good. That's accurate. This is one that has a it's lockable, and I don't see a value on it, but let's see if we can find out what the value is. If we get between these two, we can find out the total value. This one is it's a 5K because it's 4.95 K ohms, which is 4,950 ohms. And then we've got this type. There are other types too, but this is a slide. This one is a slide. So if we take a look here, if we go, I think the red and the black are the two mains. Let's see what we've got. That's 9K. If I go here, I've got 9K. Okay, let's slide it to 50%, and that way we can tell. Okay, so this is the wiper. The green wire, in this particular case is the wiper. So if I go between one side and the wiper, I got it at about 50%, and I've got about 50% of the total. So that is also not too bad. It's pretty close on accuracy. But we can vary these. I do